Hello, in this video lecture we are going to discuss the another type of decomposition. In the previous video lecture we have discussed the eigen decomposition. Now we are going to discuss another type of decomposition that is known as LU LU decomposition. An LU decomposition of a matrix A is the product of lower triangular matrix and the upper triangular matrix. So an LU decomposition of matrix A is the product of lower and upper triangular matrices. So previously we have discussed what is meant by the upper triangular matrix and the lower triangular matrix. Let's suppose in case of lower triangular matrix we will have L11 0 0, L21 L22 0, L31 L32 and then L33. All the elements above the main diagonal are 0, so this is the lower triangular matrix, and then we have upper triangular matrix as U11 U12 U13 and then 0 U22 U23 0 0 and then U33. This is the upper triangular matrix. All the elements below the main diagonal elements are 0. So now in case of LU decomposition we are going to decompose any given matrix, any given square matrix, any given n by n matrix into L multiplied by U matrix. So we are going to decompose a square matrix as the product of lower triangular matrix and the upper triangular matrix. Now the next thing is we are going to see how we can do this thing. Now the next thing is we can see how we can convert a given matrix, or how we can decompose a given matrix into LU format, how we can decompose a given matrix A into lower multiplied by the upper triangular matrix. So the first step is we have to convert a given square matrix into the upper triangular matrix. So if we want to convert this matrix A into the upper triangular matrix, this element, second row and first column, this element has to be 0. So what we can do, will perform the elementary row operations. So to convert this 4 into 0, what we can do is row 2 minus 4 by 3 multiplied by row 1. So here we are doing, let me write down, to go from matrix A to the upper triangular matrix, we are doing row 2 minus 4 by 3 row 1. So the first row, let me delete this thing, first row will remain the same, equal sign C2 and D2. So this will be now row 2 which is C3 minus bracket start 4 divided by 3 4 divided by 3 multiply by row 1. Now this element has become 0, so we have converted the matrix A into the U matrix, or we have converted matrix A into the upper triangular matrix. All the elements below the main diagonal elements are 0. Now the next task is we have to convert we have to compute the lower triangular matrix. So what we are going to do, will start with the identity matrix. So we have to, because A is a 2 by 2 matrix, so we will write down 2 by 2 identity matrix, and then we'll perform the same elementary row operations on the identity matrix but in the reverse direction. So like here we have performed row 2 minus 4 divided by 3 row 1. Now here we are going to perform row 2 plus 4 divided by 3 row 1 as row 2. So the first let me compute again. So the first row will remain same. So just remember that for lower triangular matrix we are performing the elementary row operations on the identity matrix. So the first row will be same as that of the identity matrix, and for the second row we are going to have row 2 plus 4 divided by 3 bracket close multiply by row 1. Copy and paste this formula. Now we have converted, we have got the lower triangular matrix. Now what we can do is we can go ahead and verify A as L multiplied by U. So equal sign, just select 2 rows and 2 columns, equal sign MMULT, and then first of all I'm going to select matrix L comma matrix U, bracket close, control shift enter. Now if you see, this L multiplied by U is exactly equals to matrix A. So we are basically decomposing matrix A into L matrix multiplied by matrix U, or we are decomposing matrix A into the lower triangular matrix and the upper triangular matrix. So just you have to keep one thing in mind. This is we are decomposing matrix A into L multiplied by U, and it is not equals to U multiplied by A, because the order of multiplication matters here. So we have decomposed, given this 2 by 2 given 2 by 2 matrix into L multiplied by U matrix. So now we can look at the 3 by 3 example. So the method is same. So we are given this, given this 3 by 3 matrix whose elements are 1 2 3 4 5 6 7 8 9. So now what we have to do is to convert this element so to convert this matrix A in to upper triangular matrix. So the first step is we'll convert a given matrix A into the upper triangular matrix. So if we have to convert this A matrix into the upper triangular matrix, we have to make 4 7 these elements 0 and this element 0. So what we are going to do is the first row will remain the same, and for the second row we are going to do row 2 minus, let me write down here, we are going to do row 2 minus 4 row 1 as row 2, and for the third row we are going to do row 3 minus 7 row 1 as row 3. So the first row will remain same, and for the second row I can do the computation again. So we'll have row 2 minus 4 multiplied by row 1. So now you can see that the second row first column element is 0, and copy this formula to the right. And for the third row we are going to do row 3 minus 7 multiplied by row 1. Now you can see that the third row first column element is now again 0. Now we have to convert this minus 6 third row second column element into 0. So for that purpose what we can do is, so this is minus 6, so we have to add 6 here. So what we can do here is row 3, we can do row 3 minus 2 row 2 as row 3. Let's try to do this thing. This is row 3. So the first row will remain the same. Similarly, the second row will remain the same. For the third row we are going to do, for the third row I'm going to have row 3 minus 2 multiplied by row 2. So now we have finally we have converted matrix A into the upper triangular matrix. So now to get the lower triangular matrix, I'm going to start with the identity matrix, and we are going to perform the same elementary row operations in the same order. First of all, I'm going to perform this elementary row operation and then these elementary row operations, but in the opposite direction. If I'm having minus here, I will do plus here when I'm going from identity to the lower triangular matrix. So first of all, I'm going to perform this elementary row operation but in the reverse direction. So I will have I'm having the identity matrix. So first of all, I'm going to have row 3 plus 2 row 2 as row 3. So it means that first two rows will remain the same, equal sign. This is my row 1 and row 2 will remain the same. For the third row I will have row 3 plus 2 multiplied by row 2, and I just copy the formula to the right. So this is my row 3 plus 2 row 2. So just see that when we were going from matrix A to the upper triangular matrix, we did, our last step was row 3 minus 2 row 2. Now when we are going from identity to the lower triangular matrix, so our last step is my last elementary row operation is now my first elementary row operation, and we were doing row 3 minus. Now here we will do the same elementary row operation but in the opposite direction, row 3 minus row 3 plus 2 row 2. And now I will do two elementary row operations from here, row 2 plus 4 row 2 as row 2 plus 4 row 1 as row 2, and then row 3 plus 7 row 1 as row 3. This is 7. So I delete this thing. So my first row will remain the same, and for the second row now I will have row 2 plus 4 multiplied by row 1 Now I copy the formula and paste it to the right, and for the last row I will have row 3 plus 7 multiplied by row 1, copy and I paste this formula to the right. So now this is my lower triangular matrix. This is my lower triangular matrix and this is my upper triangular matrix. Now I can go ahead and verify this thing as A is equals to L static U. So I select 3 rows and 3 columns equal sign MMU LT. So first of all I'm going to have L lower triangular matrix multiplied by upper triangular matrix, and this must be equals to my original matrix. So press Ctrl Shift Enter. Now you can see that we are getting exactly the same elements 1 2 3 4 5 6 7 8 9. So this is how you can go ahead and decompose a given matrix into a matrix A. This is how we can decompose a given matrix into L cross U decomposition. So your task for this lecture is, given this matrix A, so this is your task for this lecture. So given this matrix A, whose elements are 1 0 2 and 1 0 0 and then 0 0 minus 1. So what you have to do is you have to diagonalize and decompose this given 3 by 3 matrix. Just diagonalize and decompose this 3 by 3 matrix A using the eigenvalues.